Let's go over a few problems that deal with some 6th grade concepts together. If you'd like to download a free copy of the blank PDF or the answer key PDF, you can find a link to those below. I encourage you to grab some paper, something to write with, and let's do some math together. For number 1, we're going to go ahead and see which of these expressions below are equivalent to this expression that we're given of this 8 times the quantity of 4c plus 3. So if I were you, I would just go ahead and take this original expression and see what it is equal to. So if we take this 8 and we distribute it to both of these terms on the inside, again, this 8 on the outside means there's 8 of each of these things on the inside. So if you have 8 of these 4c's, it'd be 8 times the 4c, and there's also going to be 8 of these 3's. So if we go ahead and simplify this a bit, 8 of these 4c's really means that we have 32c, and then 8 times 3 is going to be 24. So this is going to be the same thing as 32c plus 24. That would be an equivalent expression. We can see in answer choice A that the 32c's, this term does match. However, the constant terms are not equivalent to each other. So we're going to go ahead and say that A is not going to be one of our answer choices. If we take a look at B, it looks like it matches identically. We have the right coefficient, the right variable, and the right constant term. So B is definitely going to be one of our answers. For C, let's go ahead and see if we can clean this up a little bit to see if they match. If we combine the like terms of 12C and 20C, that would end up being 32C. So that part seems to be good so far. If we take this 15 and this 9 and add those together, those constant terms, that's going to be 24. So looks like the variable term here of 32C matches and the constant term of 24 matches as well. So we know that answer choice C is also going to be an equivalent expression. For answer choice D, it looks like we have 5 of these 4c plus 3, and we have 3 more of these 4c plus 3. So if we have 5 of the same thing plus 3 of the same thing, essentially that's saying we have 8 of the same thing, right? So we have 8 of these 4c plus 3s, and so you can see that is actually the same exact expression that we had over here. Now, if you wanted to go ahead and distribute over here and distribute again, you could do that and then combine like terms, but we're going to get the same expression. So based on that logic, answer choice D is also going to be an equivalent expression. And finally for E, I think the best thing to do is just distribute the 6 to both of these terms first. If we do that, 6 times that 4c is going to be 6 times 4c plus, and then we have 6 of those 3, so we have 6 times 3, just using that distributive property, and then we have plus 8c afterwards. If we combine or just go ahead and simplify this by multiplying it out a little bit, 6 times 4c is going to be 24c. And then if we go to multiply 6 times 3, that's going to be 18. So we have 24c plus 18 plus 8c. Then if we go ahead and just combine like terms of 24c and 8c, that's going to be a total of 32c, and then we have this plus 18. So it looks like it's close. The 32c, the variable terms do match, which is good. However, the 24 and 18, those constant terms do not match. So based on that, A would not be the same expression or not have an equivalent value as the original expression we were given. And if all of this was a little bit tricky, you could also just made up hypothetical values and said something like C was equal to 2 and plug it in and see which one of these has an equivalent value to all of these. You're going to find out that these middle 3, B, C, and D would have the same value if C was 2. You could also say C is 3 or C is 4 or pick anything for C. Just stay away from C equaling 0 or 1. Those are two numbers you don't want to use because of the identity properties of addition and multiplication. Let's check out another one. Here is number 2. For number 2, it says, which question is a statistical question? Explain why. So a statistical question is a question where we can collect varying data. So we can collect data based on some different information, maybe from different people or different instances. And so if we can only collect one piece of information and it can't change, then that is not a statistical question. So if we take a look at A, it says, how tall is the pine tree? Well, if we're talking about one specific pine tree, there's only one answer to that question, so that is not a statistical question. For answer choice B, it says, how much did the plant grow in 1 year? Well, if we're only seeing how much one plant grew in 1 year, there's only one answer to that question, so that is not a statistical question. For answer choice C, it says, what are the heights of the oak trees in the schoolyard? So if we're collecting different heights of all the different oak trees in the schoolyard, then you're collecting a bunch of different information. If we're collecting data on a bunch of different trees and measuring each of their heights, then that is a statistical question. Now, we know D is not going to be statistical because we found our answer here and there's only one answer. But we can say here, the question says is what is the difference in the height of the oak tree and the pine tree? So there would only be one answer to this question because you would find the height of that oak tree and pine tree and just subtract them. And there would only be one answer to that question. So this is not a statistical question either. So for the part where it says we're going to explain why, And if we say something along the lines about how this is a statistical question because we can collect varying data and create a data set, that would be a pretty good answer for why this is a statistical question. All right, here is number 3. For number 3, Owen buys a case of bottled water. A case contains 24 bottles of water and it costs $3.59 for all that water. He's going to be going ahead and selling each bottle of water for $1.25 at a school event. The question is, how much profit will Owen earn if he sells all the bottles of water? All right, so first things first, we have to see what Owen spent on the water bottle. So keep in mind that Owen is going to spend $3.59 just to buy those 24 water bottles. So that means that he has to take out that money from his profit later. Now, what about the amount of money that Owen made? Well, Owen sold 24 of these bottles, right? And each of these bottles he sold for $1.25. So if we want to figure out how much money he made, we would just add $1.25 24 times or just multiply here. And so on the side here, if we take $1.25 and we multiply that by 24, let's go ahead and see how much money that he must have made here. So let's go ahead, 4 times 5 is 20, carry the 2. 4 times 2 is 8, plus 2 is going to be 10, so we're going to carry the 1. 4 times 1 is 4 plus 1, that's going to be 5. Keep in mind we need a placeholder here. We're done with these, the 1 and the 2 and the 4. 2 times 5 is going to be 10, carry the 1. 2 times 2 is 4 plus 1, that's going to be 5. And then 2 times 1 is going to be 2. So if we go ahead and add this all together, we're going to get 0, 0, 0, 1, and a 3. And it looks like we're going to have 2 decimal places here, so that's going to be $30. So Owen must have made $30 when it comes to how much he made from selling all the water bottles. Now, to figure out the profit or how much money Owen actually walks away with, we have to go ahead and use the 2 pieces that we just found. If we go ahead and take what Owen made and we add what we spent, then we should end up with what the profit is. And so for Owen's profit, we should take the money that he made, which was $30, and then go ahead and add on what he spent, which was this $3.59. That's going to be negative because he doesn't get to keep that money, of course. And you can rewrite this addition problem as subtraction if that's easier, however you want to think about it. Let's go ahead and take away this $3.59. So if we take this $30 and then subtract the $3.59, let's see what we're going to get on the side here. Well, we're going to have to borrow a little bit. Borrow from this 3, make it a 2. This will become a 10, but we're going to borrow, so that's a 9. Same thing here, that's a 9, and this is going to be a 10. 10 minus 9 is 1. 9 minus 5 will be 4. 9 minus 3 would be 6, and then this 2 is going to be over here on its own. So the profit here is going to be $26.41. And so Owen technically made $30 here by selling all the water bottles, but keep in mind that he spent $3.59 just to get the water bottles in the beginning. So we kind of subtract that out as an expense, and we see that he did profit $26.41. For number 4, Celeste brought 8 soccer balls to her local soccer tournament. These soccer balls represent 20% of all the soccer balls at the tournament. What is the total number of soccer balls at the tournament? So one way we can think about this is if we go ahead and make a little tape diagram here, or a double number line diagram, then we know that the 8 soccer balls that Celeste is bringing here represents 20% of all the soccer balls. So I guess the question is how many were there in total, which would be 100%, and that would be our unknown here, right? So you can see here that you could just take each of these numbers and make an equivalent ratio, or we can also just write it in ratio form or rate form. So we can write 8 to x, or 8 out of the total is equal to 20% out of 100%, or 20% out of the total there as well. So these are 2 good ways you could go ahead and write this. You can simplify that ratio on the right by dividing them both by 20. So we can say 8 to x is equal to 1 to 5. That's something that we could also do. And then you can say that, oh, how does 1 become 8? Well, you can multiply it by 8. And then how does 5 become this? Well, we can go ahead and say 5 times 8 would get you that value for x. So we can see here that x would be equal to 40. And that hopefully makes sense too, because if you can multiply this 20%, 20 times 5 would be 100. And so you can see that 8 multiplied by 5 would also equal this 40 that we got just a moment ago. So if Celeste brought 8 soccer balls to this tournament, and that represented 20% of all the soccer balls, there must have been 40 total soccer balls at this tournament. Let's check out number 5. In number 5, Ruth buys 5 yards of rope for $4. In fraction and decimal form, how many yards of rope can Ruth buy with 50 cents? So let's assume that we can buy things in 50-cent increments here. So let's go ahead and set up a rate or ratio. So I think we're going to go ahead and put money first. So let's put the $4. That's going to get us 5 yards of rope. So I'm going to put the money on top and the rope on bottom. let's see, we're going to figure out for 50 cents. So let's actually go down to $1 first. I think that's going to be a little bit easier to think about. So if we get down to $1, how do we get there? Well, $4 divided by 4 would get you $1. So what's 5 divided by 4? Well, on the side here, we can just do this division, 5 divided by 4, all right? So how many times does 4 fit into 5? Well, it fits in 1 time, so 1 times 4 is 4, and the remainder here is 1. Now, we're dealing with decimals, so let's go ahead and bring down a 0 and add those decimals in. 4 into 10 is going to be 2 times. 2 times 4 is 8. 10 minus 8 is going to be 2. Looks like we can bring another 0 down here and see if we can end this one. So 4 into 20 would be 5. 5 times 4 is going to be 20. You can see the remainder here is going to be 0. So for $1, it looks like we're going to be getting 1.25 or 1 1/4, I guess you could say, yards of rope here. All right, so that's going to be for $1. Now, what if we only have 50 cents? Well, we can go ahead and write another equivalent ratio here. So 50 cents is going to be 0.50. And so how do we get from $1 to 50 cents? Well, we go ahead and divide by 2. Go ahead and divide by 2 here. So here's the interesting part is we have to take this 1.25 yards and then divide that by 2. So we can do this a couple of different ways. So we're already in decimal form. So let's go ahead and take this 1.25, put it just like this, and then divide that by 2. So let's see, 2 isn't going to go into 1, but 2 goes into 12 6 times. 6 times 2 is going to be 12. 12 minus 12 is going to be 0. If we bring down the 5 here, 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is going to be 1. Let's go ahead and bring another 0 down here. And 2 into 10 is going to be 5 times. So 5 times 2 is 10. And that remainder is now going to be 0. So in decimal form here, we're going to get 625 thousandths yards of rope for this 50 cents. So we have our answer technically in decimal form here for what we can get with 50 cents, but what about fraction form? So in terms of fraction form, this is a decimal. I'm going to go ahead and write this on the side here. So we have our answer in decimal form. This is 625 thousandths. So it says, what about in fraction form? Well, in fraction form, we could rewrite this as 625 over 1,000, right? And then we can go ahead and just simplify this down using some common factors. So you can go ahead and divide this by 125 and divide this by 125. Or if you didn't see some larger numbers, you can just divide by some smaller factors like 5 and use your divisibility rules a little bit. We're going to find out eventually that this is going to end up being 5 out of 8. All right. So in terms of our answers here, you can either by our amount of rope here, you can either say it's going to be 625 thousandths of a yard, right? Or you can say you can buy 5/8 of a yard, which is probably going to be a little bit more common. If you're going to buy rope, you're going to probably buy them in fraction form as opposed to decimal form, but it may just depend on the case. And so for 50 cents, you can buy this amount of rope. All right, for number 6, let's go ahead and see if we can go ahead and find the greatest common factor and the least common multiple of 42 and 28. So I'm going to go ahead and just use our ladder method here. We have 42 and 28. Let's see if we can find out the GCF and LCM here. So something in common both of these numbers have. I'm going to go with 7 here, right? 7 times 6 is 42, and then 7 times 4 is 28. Then you check to see if you can pull out another common factor here. For 6 and 4, you can both pull out a 2. So 2 into 6 is 3 times, and 2 into 4 is going to be 2 times. I think 3 and 2 are relatively prime just because they're neighbor numbers, so we can't pull out anything else. So on the side here, this 7 times 2 would be the greatest common factor. So I'm going to go ahead and say here that the GCF, or the greatest common factor here, is going to be 14. And for the LCM, or the least common multiple, that's going to be the first time these two numbers meet. And what you can do here is you can just multiply 28 times 3 to get the LCM, or you can multiply 42 times 2 to get the LCM. Either way, you're going to get 84. And if you prefer to use neither of those diagonals, you could also multiply everything on the outside here for the LCM as well. If that rings a bell and that's helpful to you, you can multiply everything on the outside because that makes kind of like that L shape, and that should also get you 84. All right, let's check out number 7. This one's kind of an open-ended problem, or a question that has several parts to it that go off of it. For number 7, a rectangle has the known vertices of A, which is at -5, 3, B, which is at 8, 3, and C, which is at 8, -7. We're going to go ahead in part A here and determine the ordered pair of the missing vertex, because it has to have 4 if it's a rectangle, right? And they only gave us 3. We're going to argue and provide evidence for how we know that is correct, right? So let's go ahead and just visualize what this looks like. So on the side here, I'm just going to go ahead and sketch a coordinate plane so we can see where these points are. Now for point A, we have -5, 3, so that's going to be over in quadrant 2. So I'm going to go 5 to the left and 3 up. I'm going to say point A is right about here. For point B, we have 8, 3, so that's going to be to the right, and then it's going to be up, so it's in quadrant 1, so here's B. And then for C, we have 8, -7, so that's going to be 8 to the right and 7 down, so here is point C. So you can see these are 3 points that were given. So you can hopefully now visualize a little better where these points are and kind of where they are in terms of spatial reasoning and seeing where they are in the quadrants. And you can see that we kind of have this rectangular form, and we're going to try to maybe hopefully guess that point D is somewhere over here, right? And so they're asking us to find out this last point. So if this is a rectangle, then D has to be directly below A, and D also has to be directly to the left of wherever C is, right? So we really just have to steal the X value from A because it's not moving left or right, and we need to steal the Y value from C because it's not moving up or down. So if we can go ahead and find out the X value and the Y value and use those combination of information, then we can find out the point D, all right? So if we're gonna go ahead and write down where point D is located, I'm just going to use a dotted line because we're going to pretend we don't really know that that's there. That's going over here. So point D here, we're going to say point D is going to have the same X value as A, where the X value of A is going to be -5. So I'm going to say it's -5. And then it has to have the same Y value as C, because again, it's the same height as C. So the Y value of C is going to be -7. So point D is going to be at -5, -7. So in terms of making an argument and providing evidence, we should say something on the lines that point D must have the same X coordinate as point A, just because it is above or below it, and that point D must have the same Y coordinate as point C because it is next to it or horizontal to it. Point A and point D are vertical to each other, so they share the same X coordinate, and point C and point D share the same Y coordinate because they are horizontal to each other. That should help back up our answer that D has to be at -5, -7 over in quadrant 3. All right, for part B, let's go ahead and see if we can find the perimeter of this rectangle measured in units. All right, so just wrote down each of those coordinates of A, B, C, and D. So let's go ahead and see if we can find the perimeter now. So to find the perimeter of a rectangle, we know that the formula is going to be twice the length plus twice the width, or just adding up all the values along the outside here. In this particular case, I think our length here is going to be the length of whatever AB is equal to, right? So if that's the case here, to figure out the distance between A and B are in different quadrants, so we're going to have to add the absolute values of their non-matching coordinates. So that's going to be the absolute value of -5 plus the absolute value of 8. If we go ahead and do that, then the absolute value of 5 is going to be 5, and the absolute value of 8 is going to be 8. So we know that the length of this rectangle is going to be 13 units. Now in terms of the width of this rectangle, we can go ahead and say that is going to be the length of B to C, or you can say it's on the other side, but they're going to be the same. From B to C, it looks like these points are in different quadrants as well. So we're going to go ahead and similarly add the absolute values of their non-matching Y coordinates here. So it's going to be the absolute value of 3 plus the absolute value of -7. So the absolute value of 3 is going to be 3, and the absolute value of -7 is 7. So the width here is going to be 10 units. That's going to be how long the width is. And so if we substitute this in, we're going to say it's going to be 2 multiplied by the length, which is 13 units for the 2 lengths that we have in the rectangle. And then we're going to say 2 times the width, which we know is 10 units each. So all the way around this, the top and the bottom, where the 2 lengths together, is going to be 26 units. And then the left and the right side, where the 2 widths here, is going to be 20 units. So altogether, the perimeter here is going to be 46 units. And so the perimeter of this rectangle measured in units is going to be 46 units. For part C, you don't have to do a bunch of this work all over again. For part C, let's just use the information from part B. So we know the length of this is going to be 13 units, and we also know that the width of this rectangle is 10 units. So if they're asking us to find the area of this rectangle measured in square units, we can just use the formula area is equal to length times width. And so the area here is going to be equal to 13 units along the length multiplied by 10 units along the width, and 13 times 10 is going to be 130, and then we have this 130 units squared. And so the 2D space measured inside this rectangle is going to be 130 square units. Here's part D. All right, so for part D, we're going to be changing units here. So So they're giving us a conversion here and saying that 1 unit is going to be the same thing as 3 meters. So let's think about this this whole context in terms of units and then converting to meters. Well, earlier we said the length we knew of a rectangle was going to be 13 units, right? And we knew the width of that original rectangle was going to be 10 units. Well, we know the conversion here is that 1 unit is the same thing as 3 meters, then we can go ahead and multiply this thing by 3 to convert this into meters. So our new length here, 13 times 3, is going to be 39 meters. And if we go ahead and take our width and multiply that by 3, then our new width here is going to be 30 meters. And so we have our new measurements of the length and the width measured in meters, so we can use the same formula for perimeter. So the perimeter here is going to be equal to 2 times that 39. 39 is going to be the length. Let's go ahead and put 39 inside there. And then plus 2 times that width. And that width here we said was 30. All right, so 2 times 39, that's going to be 78. So it's going to be 78 meters all the way around the top and the bottom, or the 2 lengths, plus 2 times 30 is going to be 60, so it's going to be 60 meters. So measured in meters, 78 plus 60, that's going to be 138 meters. Now, if you knew that we could have just taken the perimeter over here of 46 and multiplied it by 3, we would have also got 138. That is okay. This would be a pretty thorough way of writing out our answer, and very clear work to show that though. For part E, we're being told that each unit represents 3 meters again. We're going to go ahead and determine the area measured in square meters. So we're using the same conversion here that 1 unit is equal to 3 meters. So we have to be very, very clear about what's going on here, that in the length, we knew that that was going to be 13 units. That was just in units. And the width we said was 10 units. And we just said that if we're converting these over, we're multiplying this by 3 and multiplying this by 3, that the new length here, like we said earlier, was going to be 39 meters. And then the new width here, or the width measured in meters, is going to be 30 meters. Okay, so if we go ahead and plug this into our formula for area, which is length times width, then we're going to have some different values here. So the area is going to be equal to, and the 2 values we're going to plug in, the length is 39 meters times this 30 meters. Now, if we multiply those 2 values together here, we're going to get 1,170, and that's going to be meters squared. Now, something that crosses a lot of people's minds are, could we have just taken our answer over here, which was in square units, and multiplied it by 3 to get this value over here? If you go ahead and try that, you're going to notice that's not going to work out. However, if you go ahead and multiply that by 9, this 130, if you multiply that by 9, you will get this 1170, and that's just because you're multiplying it by 3 in both dimensions. So again, the length and the width both have to multiply by 3. So if you wanted to go straight from this answer to this answer, make sure you multiply by 3 in both dimensions so that we get the area in that new dimension, because 1 unit was 3 square meters. And so I basically just said a little bit about this, but in part F, that's basically what they're asking us to explain here. So the key difference here is that from part B to part D, if you're going to go ahead and find the new perimeter, since perimeter is a one-dimensional measurement, you can just multiply the perimeter in units by 3 to get it into meters. However, when you're looking at part E, while on the other hand, area is a two-dimensional measurement, so if you're going to turn the area in square units into square meters, you're going to have to multiply the area in square units by 9 or by 3 twice to do so. That's the key difference between getting our answer from part B to part D and then getting our answer from part C to part E. The shortcut from getting our answer in part B to part D is just taking our perimeter and multiplying it by 3 because it's one-dimensional, and the shortcut from getting from part C to part E is taking our area and multiplying it by 3 2 times, or multiplying it by 9, just because area is two-dimensional measurement. Alright, so that just about wraps up this video on a few different practice problems dealing with some 6th grade concepts. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.